Okay, lab 3, number 4, you're doing a graphic solution of a force problem. I changed the values because I don't want to rob you of the fun of solving the problem yourself. So I'll do a different one, but it's very similar. And so I'm going to show you how to do this. But if you have some idea what to do, before we start, just try doing this as a sketch by eye. That's what I'm going to have to do anyway, and see how close you can get to the answer. If you don't know what I'm talking about, just hang on and you can see me do it. But it's good practice to draw good vector diagrams to scale without a ruler and protractor. Okay? So now I'm going to do it. Pause the video and try. If not, just watch me. So I'm going to do vector 1 first. And if I'm on a piece of paper, I'm going to pick a 10:1 scale. So I'll make a 120 gram vector 12 centimeters long, because I want to be able to fit it on a sheet of paper. So I'm going to pretend that I have a ruler and a protractor. And I'm guessing I should start low because I see these are going to go up. So I'm going to start here. I'm going to put a kind of a dotted line, x and y component, and start the vector here. And I've got to go 12. I'm just going to pick a length. I'm estimating this to be 30 degrees. And I'm calling that 12 units. So now the next one, I got to start at the tip of this. So I'm imagining x and y coordinates at the tip of the arrow. And then I have to go at 150 degrees. So 150 is 30 degrees away from 180. And I've got to make the thing, if this is 12 units, that has to be 15. So it's got to be a little longer. So I'm guessing the angle. And I'm going to make it a little bit longer. I'm guessing, right? You should be measuring this with a ruler, not guessing, and measuring the angles with a protractor. So what I'm doing is I'm calling this, just eyeballing it, 150 degrees. You would do that with a protractor. This angle I'm calling 30 degrees. But you would do it with a protractor. You'd get it really carefully do it with a protractor. This line would be exactly 12 centimeters. This line would be exactly 15.0 centimeters. Oh, it's 140 degrees, excuse me. Okay, I'll change that. Okay, and now the last vector needs to be 50% longer than the first vector because it's 18 instead of 12. And it has to be at 220 degrees. So let me put in an axis here. That's 180. So I'm going to call this 220. And then I'm going to just, since I don't have a ruler, I'm going to guess that that's 50% longer. And so this angle is 220. You're measuring with a protractor, right? And the length of this, F3, should be 18 centimeters. This would be 15 centimeters. And this would be 12 centimeters. So based on this, notice I didn't really use a protractor, but watch how close I can get to the answer. The sum of F1, F2, and F3, the resultant vector, would be this vector. But since you're asked, that's one of the things you're going to find, it's that vector. But if you're asked to find vector 4 so that you get back to 0, it's the same vector but in the other direction. So I'm going to find this vector. So the first thing is I need to know the magnitude. So look at the length of this. And how does it compare to the length of that? Well, my 15 centimeters doesn't look right. But I'm going to guess that this is 13 centimeters. So if it's 13 centimeters, then that means the magnitude of the answer is 130 grams. And this angle looks like, you see 180, this looks like 160 degrees. So based on this sketch, I'm getting 130 grams and 160 degrees for R, the resultant of those three vectors. 130, 160 degrees. And if I wanted F4, that would be in this direction. It would still be, right, the F4 would still be 130 grams. It's the same length, but the angle would be this way. And if this is 160, then it means that angle would be a negative 20. I would just subtract 180. A negative 20 degrees, or what's equivalent to negative 20 is 340 degrees. That's the same angle. So that's how we got that. Okay, now I discovered that the iPad has a ruler and a protractor. So I'm going to try and redo this problem and see what I get. I'm going to actually try and do it to scale. So I'm going to pause the video and do that. Okay, notice a few things. One, we have the, I recorded the answers from the sketch. Then I got the ruler and protractor. It won't show you the ruler and protractor. I have to do this with the video off. So what I did was I draw a line using the ruler and protractor. This is at an angle of 30 degrees and it's 12 centimeters long. Now I'm going to do the next line, which is going to be 15 centimeters long at 140 degrees. So I'll pause the video. So actually I decided to complete the whole diagram. You can see it here. I just want you to see it before I label it. You can see it went over the writing, but that's okay. And luckily it didn't go off the page before I finished it. So let me label things and come back. Okay, so let me just review what I did. The first line I drew 12 centimeters long at 30 degrees using a ruler and protractor. Then I went back and I measured this angle of 140 degrees. I put the ruler at 140 degrees and drew a line 15 centimeters long to represent 150 grams. Then I put the protractor at 220 degrees and drew a line along the ruler 18 centimeters long, and I ended here. And then I drew the line. First of all, I measured the distance from here to here, and that was 15.5 centimeters, so that's the length of the fourth vector. And the direction, if I go from here to here, which would be vector 1 plus vector 2 plus vector 3 equals this. So this is the R vector. That's 165 degrees. If I were to turn that around going this way, it would be what? A negative 15 degrees. So notice I had 130 at negative 20. So I was off 5 degrees and about 25 grams. Not bad for a rough sketch. So our results now are for R, 155 grams at 165 degrees. And so when you do the lab, you're going to take a picture of this figure, make sure all the writing, all the angles are labeled, all the numbers are recorded, and make sure that you do this entirely just with a ruler, protractor, pencil, and paper. No calculations. You're supposed to solve this problem graphically. That being said, what I'm going to do now is pause the video and solve it using mathematics, the components method, and see how that solution compares to our graphic solution. Okay, you might want to practice this before I actually do it. You see I set up a table, all three vectors, and I'm going to find the components and write them down and get the components of the resultant vector, the sum that is, of these three, by adding the x components, adding the y components, and the equations that I use to get the components are on the equation sheet. It's written as ax, and what the way to read this is the x component of any vector is equal to the magnitude of the vector times the cosine of the angle. So to get f1x, I multiply the magnitude of the vector f1 times the cosine of the angle theta 1. That's going to be the 120 grams times the cosine of 30 degrees. And to get the y component, the equation is ay equals a sine theta. So to get f1y, I multiply f1 times the sine of theta, the 150 grams times the sine of 30 degrees. So just, if you want to practice, complete that, and then you can see if you get the same answers that I do. Oops. -14. Okay, we're almost done. If you did this for practice, check your numbers. These are the calculated results. When I add all these together, this is the x component of the resultant vector and the y component of the resultant vector. And if you go to your equation sheet, you'll see that the magnitude of a vector is the 2 components squared square root, just the Pythagorean theorem. So when I put these numbers in here, this is the result I get. And to get the angle, you have the equation that theta equals the inverse tan of the y component over the x component. And so if we take these numbers, y component over the x component, it will actually give you a negative 15 degrees on your calculator. But if we want r, we know that that's the vector in this direction. It has to be 165, not negative 15. If you want f4, the vector of which the sum of the 4 gets you back here. So notice the difference between r and f4 is just the direction. R is the vector that's equivalent to the sum, and f4 is the vector that when you add it to this, you get it back to 0. That would be the force table vector. So just distinguish between those two. The difference is direction. Okay, so finally, if we compare that to the answer I got, the answer we got was 165 degrees, and here we got to 3 significant figures, 165 degrees. So the graphical answer and the calculated answer to 3 significant figures are exactly the same, and the measured answer with the ruler is and rounds to 154. This is 155. That's one part. That's one difference, a difference of 1 out of 150. It's less than a 1% error. So if you do this carefully, you should get an answer within about ideally less than 1% of the calculated answer. Okay, good luck.